So first of all, on behalf of Struct Center, I would like to warmly welcome you all in this introductory session for the upcoming live training program under the title of Professional Approach for the Design of Complete Structure by using ETABS RCDC along with the advanced Excel sheets. So there are four important things over that. You need to take the command, you need to take the knowledge over that. All four important things are there. So what are those four important things? Try to understand. Amongst those four important things, very first is design software. In current scenario, if you like to work in any consultancy, in any company, or if you want to start your own consultancy, so very first thing you need to have the knowledge about the softwares. Without having the knowledge about the software, you cannot design any kind of structure. If suppose I am giving you like G plus 30, 40 floor building, and if I am asking to design that structure, so if you are going to adopt the approach for design of that structure as by manual approach, so like it is not possible to do that. It is close to impossible to design that complete structure with manual approach. So that's why we need to look at the softwares. So that software will help you to complete that project, to complete your work with a short period of time with least of effort. So your first job is to find out what different softwares are there in industry, which softwares are in use. So there are so many softwares like ETABS software is there, Foundation Stat Pro software is there, SAP software is there, Stat Pro, CSI Bridge, CSI Safe. So the Tekla is also there. So there are so many different types of the softwares. So your job is to find out which software is in demand in industry and what is the use of that software as per your requirement, as per your interest, or the consultancy in which you are looking to work, which that consultancy working on which software, and you have to take the command over that software. You need to get the hand over that software to deal any kind of project. So very first thing, when you are going to approach, so they will ask about how many softwares you are knowing or how many softwares you are having the command. And if you are after this software knowledge, the next thing is very important to have, that is your basic concept, basic knowledge about the structural design, about the structural response, about the structural behavior under the application of different kind of the loading. So like if suppose if I am going to apply the gravitational load, so my structure, how my structure is going to deform. If I am going to apply the lateral load, how my structure is going to be deformed. What are the different types of the beam? What are their respective flexural behavior, deformed shapes? What are the different materials? What are the different grades of the materials? If you are talking about the concrete, so for which level of the for which number of floors, which grade of concrete we have to adopt? What does mean by the earthquake loading? What does mean by the wind loading? What all these different loads are going to affect over your structure? What is the bending moment diagram? What is the shear force diagram? There are so many things are there. What does mean the short column, long column? What are their response under the application of loading? When you will call any column as a long column, short column? What will happen if your column is going to become long column, short column? So there are so many things are there. And that will counted into your basic knowledge, your basic concepts. Unless and until you are not having the knowledge about the structural response, having the knowledge about the software is useless. If you are having the knowledge about the software only, so it is just a clerical job. If you are going to work, anyone can use that softwares, but for understanding of the algorithm of that particular software, you need to have the basic knowledge. Then only you can validate the results of the softwares. So having the knowledge of the software is not enough only. You should also have the knowledge about the basic concepts. And with these two important requirements, the third requirement you have to fulfill, that is having the knowledge about the design codes. See, if you are going to design your structure without following the design codes, without having the knowledge about the requirements of the design codes, Indian standard design codes, you are not going to design your structure as economical as well as stable. Without following the design code, if you are going to design your structure, definitely your structure will be uneconomical as well as it will be unstable. right? So like we cannot take the surety of stability of your structure, which is you are going to design without of following the clauses of the codes. So you need to find out what are the different codes are there. So there is IS 456, the basic code for the design of your RCC structure. So this code will tell you about what minimum percentage of reinforcement you have to maintain in any particular type of the element, beam, column, slab, foundation, whatever the element you are going to design, how much the minimum percentage, maximum percentage, number of bars, what should be the spacing of that bars. There are so many things there are needed to understand. If your column is going to become long column, so what to do with that long column, what additional moment you have to provide there, what additional reinforcement you have to provide there, that everything were given by your IS 456. Then IS 800 2007, the code for the design of your steel structure. Then if suppose you are going to assign the load over your structure, okay, there are different types of the structure based on its utility. So some structure may be commercial, industrial, residential. Okay, so if for different structure, if suppose you want to assign the load, so how much the load you have to assign for different categories or for different types of the structure based on its utility, so that will be given by your IS 875 part 2. Then what for part 1, what for part 3, you need to know. If suppose you want to assign the earthquake loading, so which code you have to follow? IS 189 2016. If you would like to assign the if you want to do the ductile detailing, IS 13920. So this all codal knowledge, codal information is very, very important if for design of any kind of structure. As I told again, I'm repeating, if you are going to design your structure without of following these design codes, without of having the knowledge of these design codes, definitely your structure will be uneconomical as well as unstable. We cannot take the surety of the serviceability of your structure. And if suppose you are having the knowledge about the design code, okay, thereafter, if suppose you are having the good conceptual understanding about the structural response, and also you are good in handling of the software, these three assets will also not making you as a professional structural engineer and the confident structural engineer unless and until you are not having the experience of dealing the real example projects. That's the fourth important, and it is the most important point that might be in your experience. Actually, when you are going to approach any consultancy, they will first ask a question like how many years of experience you are having. Okay, so like what does mean by that experience? Try to understand. They are expecting that they are asking that how many real example projects you have completed on your own, or whether they want to know whether you are capable of dealing the complete structure on your own or not. If suppose I am handling any project, any architecture plan, if suppose I am giving you, and if I am asking complete it so that I can send it for the site execution, so you have to ask a question to yourself whether you are capable or not to complete any project from architectural drawing to till the releasing drawing for the site execution. And there are so many things for the completion of any real example project. I will talk about those all things on later stage. Okay, so here the experience means that, so these four things are very important. Very first is your design software, second one is the basic concepts, and third one is your design codes, and the fourth one is your experience. So I am asking to all of you, do you have the command over all these requirements? If you are saying yes, that's well and good. You are ready for the industry, you are ready for the consultancy, you are ready to start your own consultancy, your own firm. But if your answer is no, then what? Without of having these all skills, you cannot design any structure. So no need to worry about if you are not having the command of any on all these four requirements or any of these four requirements. You don't need to worry about. We are giving this live training program. There you will get all. We are trying to fulfill all that requirements through this training program. So what we are going to cover in this training program, we will talk in detail. See, this complete training program will be divided into 3 levels. In the first level, that will be what? Your beginner level. In the second level, we are going to cover intermediate things. Okay, that will be intermediate level, and add all the advanced concepts and knowledge and practical things we are trying to cover in advanced level. So that after completion of this training program, you will be able to not only able to handle the software, but also you will able to design the complete structure of any number of floors. So those person who are not having the knowledge about the software, those person who has not even have like open this ETABS software, they can also learn, they can also start learning. Okay, because we are going to start from scratch and we are coming up to the everything. So from nothing to everything we are trying to complete through this training program. So let's talk first what we are going to cover in the beginner level. So in the beginner level, we will talk about the detail about the software. We will talk about the details about the software. What is the introduction of this software? What is the basic commands of these softwares? Okay, and then we will do the validation of this software, whether the software is giving the result right or wrong. Okay, software is just a tool. If you are giving the wrong input, software will also give the wrong output. If you are giving the right input, software will also give the should also give the right output. So you should capable of validating the results of the software. We cannot blindly trust over the software results of the software. We have to validate that. So first, in the first part of this first level, we are trying to understand about the software. It's the introduction, it's the basic commands and all. Then we will validate the software. After the validation of the software, we will go in deep about the basic settings of the software, all the basic and advanced commands of the softwares. Everything we are trying to cover about the understanding of the software. And with all of that, we will take one dummy project, one sample project, and there we will try to cover everything in respect of modeling, assignment of the load, and performing of analysis. Everything we are trying to cover, so that the objective of taking this covering all the content in this beginner level is to make you all confident with the software, familiar with the software. Unless and until you are not familiar with the software, unless and until you are not confident with the software, unless and until you are not capable of managing the all inputs and outputs of the ETABS software, you cannot go for the real example project. You cannot do the actual practice. So that's why in the beginner level, after the completion of this beginner level, you will be confident with the software. You will be like you can do anything with the software confidently. Then after this beginner level, we will come to your second level, that is intermediate level. So what we are going to cover in this intermediate level, try to understand. Here in this intermediate level, we are going to take a real example project. Okay, real example architecture plan we are going to take. Like suppose you are going to work as a structural engineer, and if you are getting any job, any work. So as a structural engineer, the work or job you will get from your architect. So architect will send you architectural plan. So suppose this kind of architectural plan coming to you to complete the project as a structural engineer. So what's your job? What you have to do? Okay, so this kind of a complicated architectural drawing will come to you. If you are going to deal for the real example project, so that will not be a simple one. Most of the training centers, most of the trainers, what they are doing, they are giving the training on the sample projects, simple projects, that is square, rectangular shape. But that is not the job. When you are going to deal any real example project, there will be a lot of challenges, and we are trying to cover that all challenges so that you will be ready to deal any project. So this kind of complicated architectural drawing we are going to take, and after getting of that architectural drawing, we have to read that architectural drawing. Your next job is to understand the architectural drawing. So what are the important points to understand that architectural drawing we are trying to cover in detail? After that, your job is to decide the preliminary section sizes of the elements. What should be the preliminary section size of the column? What should be the preliminary section size of beam, column, slab, foundation? That all you need to decide on early stage. Yeah, everything is going to be decided on later stage after the completion of the design. But to start the modeling, to start the preparing of structural framing plan, so you need to decide the preliminary section sizes of the elements. So how to decide the preliminary section size of the elements? So for that, if suppose I am talking about the preliminary section size of the column, so how you can decide the preliminary section size of the column? So at different stages, we are going to take the help of our advanced Excel sheets. Okay, so that Excel sheet will tell you what should be the preliminary section size of the column, what should be the preliminary section size of the beam, what should be the preliminary section size of the slab. So there are some thumb rules also there, some of the real practices are also there. So all that combinedly we are going to look at to decide the preliminary section size. Some conceptual understandings are there, are needed to understand concepts for deciding the preliminary section size. Then only you will be able to decide the sizes. Okay, once you decided the preliminary section size of the column, decided the preliminary section size of the beam, slab, then what next? You have to prepare the structural framing plan. What does mean by this structural framing plan? You need to know. Most of the like beginners, they are not aware with the structural framing plan, what it means. Okay, so structural framing plan means the presence of the column and beams, slabs, its position. Okay, that is on which your structure is going to be stable. So this is called as structural framing plan. So here we also have to decide how to decide the orientation of the column. If I am taking here as horizontal orientation, why I am not going to take it as vertical? What will happen if I am going to change from horizontal to vertical? Which one is the right one? That I need to know. Okay. So like that, we need with all of this consideration, we have to prepare the structural framing plan. And once your structural framing plan gets ready, okay, then you have to prepare the center line plan. Okay, what does mean by this center line plan? Why it is needed to prepare the center line plan? What will happen if you are not preparing the center line plan? And if suppose you are not willing to prepare the center line plan, then what is the option? So lot of things are there. Okay, suppose you are prepared the center line plan or grid lines. Thereafter, what next? Your next job is to work with the ETABS software. You have to turn to ETABS and then your work is going to start with the ETABS. Okay, so in this ETABS, first thing you have to prepare the grid lines. Very first thing you have to prepare the grid lines. Without what is the use of these grid lines, what is the importance of these grid lines, you need to know. That all I will cover in the training program. And to prepare these grid lines, we have three approaches. We have three methods, we can say. So what are those methods? The offset point method is there, ETABS templates, ETABS quick template option is there, export and import approach is there. So these are the three methods. I am talking in detail about these all methods in our training program. How to prepare these grid lines by these three options. And also we will talk under which situation, which option will be more suitable. Which option will be more convenient in different situation. Okay, so that kind of things we are trying to cover. Thereafter, after the completion of this grid lines, then what next? Thereafter, what we have to prepare we have to model the columns over the grid lines in respect of your structural framing plan. In respect of your structural framing plan, you have to model the columns. Okay, so what important things you have to take care for the modeling of the column, you need to know. But before of the modeling in ETABS software, very first thing is what? You need to define the material properties, you need to define the section properties, you need to define the load patterns, okay, you need to define the load combinations. So these all are the basic things. If suppose you want to define the slab element, okay, just go to section, go to slab. If you would like to model the slab, so there's two options. One is shell element, one is your membrane element. Okay, shell thin, shell thick. So what is the difference between all these types of modeling of the slab? Okay, when to consider a shell element, when to consider the membrane element, that we will learn in detail. Okay, now we will define the material properties, section properties, load combination. With all that definition, you have to proceed for the modeling. you have to model the columns. Okay, once the modeling of the column has been done, you have to proceed for the modeling of the beams. Okay, so modeling of the column, there is two approach. One is the basic approach, another one is the advanced approach. So we will see basic approach as well as advanced approach for the modeling. So within a short period of time you can complete the modeling of the column. After that we will see how to model the beams. Okay, there are different types of the beam: curved beam, zigzag beam. There are different types of the beams. Okay, so how to model all that different types of the beams with the basic approach or with the advanced approach. Thereafter we will look at how to do the modeling of the slabs. Okay, different kinds of the slabs are there. If suppose circular slab is there, curved slab is there, how to model that, all different kinds of the slab, that will cover in detail. So overall we are trying to cover at this stage about the modeling. Once your modeling has been completed, we will proceed for the modeling of analysis. But before of the analysis, you have to assign the load. In respect of that assigned load, the analysis is going to be done by the software. So what are the different loads? Wall load, area load. What is the conversion from kg to kilonewton? There are so many things needed to understand about the conversion, load assignment, load calculation. We at different stages we are using the advanced Excel sheets for the assignment of the load, for the calculation of the loads, and with all that calculations we are going to assign the load over your structure as a wall load, as a area load. Let me show you. Load assigns under the SIDA load pattern, how to assign this load. Okay, that we will see in detail. Then thereafter we will look at how to define the flow diaphragm. What does mean by this flow diaphragm? Pier labels. What does mean by this pier label? Why it is needed to define pier labels? Response, this earthquake loading, wind loading, everything we are trying to cover in detail. What is the concept of uniform load sets? How this will help you for the assignment of the load? So trying to understand, trying to do the things with the software with basic approach as well as with a master approach, with advanced approach. Okay, so with all of that we will complete our model in respect of its modeling, in respect of assignment of the load. And there are so many things for the calculation of the load. Okay, we have to look at IS 875 part 1, part 2, part 3 and IS 1893 2016 for the assignment of the load over your structure. And here we are not having that much time to talk all those things in detail. We are having the short period of time. That's why I'm giving the overview what we will do in this training program for the completion of a real life project. Okay, so we will complete the model, then we have to check that model, and lot of things we have to check to ensure that whether our modeling is right or wrong. See, if your model is wrong, all the later things will be wrong. Your analysis will be wrong, your design will be wrong, your scheduling will be wrong, your detailing will be wrong, your final design report or schedule detail or sheets will be wrong. So you have to take care while the modeling, okay, whether your model is right or wrong. Okay, suppose your model is, actually lot of things are there to check your model. I'm not going to talk about all those things. Okay, so once, if suppose I am satisfied my model is what correct, I can proceed for the analysis. Okay, so you have to proceed for the analysis, and once the analysis gets completed, you have to look at the analysis results, whether the analysis, whether the software has been done in a right way or not, whether all the load has been transferred or not, each beam is carrying the load or not. You have to ensure that whether each column are carrying the load properly or not. How to see the result in this model. Okay, if suppose I want to see the bending moment, so there are so many load combination. What does mean by this load combination? How to define this load combination? There is a very interesting concept and contents are there to understand the load combinations and defining the load combination. Envelopes. What does mean by the envelopes? When to define the load combination envelope? What is the use of that load combination envelope? Everything is there in detail. We are trying to cover. Okay, so suppose in this factor load combination, I would like to see the bending moment. So this, let's say, apply. So this is a bending moment diagram. Okay, what does mean by this red yellow color, what does mean by this red color, what does mean by these values. Okay, why we are going to look at the bending moment along the axis 3 3 only, why not along the 2 2? So many of you are knowing very well we have to see the bending moment about the 3 3, but if I am asking what is the reason why we are looking at the result along the 3 3, for the shear we are looking at the result along the 2 2. So what is the reason why we are looking? Okay, most of the trainers what they are saying that to check our model we have to perform the checks, but that is not only the option. Sometimes what software is doing, software even in your model the errors are present, but software is not showing that error even after checking with this analyze and check model option. So that kind of error you have to catch with the analysis results. So by looking at the analysis result I can find that is there any error in my model or not. So how to do that, that also I will let you know in detail. Okay, then which beam is simply supported beam, which beam is cantilever beam, which beam is fixed beam, how you can identify that. And if suppose any beam that should be simply supported but it is the cantilever, it is the fixed one, so how to make that particular beam as a simply supported beam if it is, then how you can identify which beam is the primary beam, which beam is the secondary beam, which beam is the tertiary beam. Okay, so everything you can understand what is the deflection limit, how you can ensure that whether the beam is with the allowed deflection limit or not, whether it is exceeding the deflection limit or not, everything we are trying to cover in respect of the beam. Likewise we also have to check your column, how much the load is going to be transferred to your column, your load is properly carrying the your column is properly carrying the load or not, whether that load is beyond the limit of the column or not. Okay, so in the ETABS software itself you can see the result, but if suppose you want to see the result in detail in tabulated form, so how you can extract the results of the ETABS software in a tabulated form in Excel format, all the result, how you can export the results of the ETABS model definition of the ETABS software, analysis result of the ETABS software, design result of the ETABS software for in Excel format, in a tabulated format. Okay, how you can apply the filters over that, lot of things are there to understand. That all we will try to cover. Okay, so like suppose you have completed the analysis and you are ensured that your analysis is right. What next step you have to proceed for the design. Okay, you have to complete the design. So before of the design you have to do lot of settings, lot of important settings. Without of that setting, if you are going to perform the design, definitely you will get the wrong result. Most of the times even our participants or some unknown person also are contacting with us, like they are asking my column is failing, my beam is failing, what to do with that beam, what to do with that column. So if I am going to if I am checking their model, okay, when I am checking their model, so basic things they have not executed, then how they are expecting they will get the right result, right? So like it is not only after the completion to click over the design result and design will be done, and that design you can trust over that design result. This is not the real practice. This is a big blunder. Try to understand. So you have to do the first settings. Before of the modeling, some settings are there. Before of the analysis, some settings are there. Before of the design, some settings are there. Likewise, after each steps, checks are there. Like suppose you are going to do the modeling. So after the modeling, checks are there, whether you have performed everything right or wrong. After the analysis, some analysis checks are there to ensure that whether the analysis is right or wrong. After the design, some checks are there whether the design is properly completed or not by the software. So a lot of things are there for the completion and with the right practice to avoid the blunders. Okay, so suppose I am going to perform, I am not going to cover all those things here. I am just going to click over this design. So once you click over the design, the software will design your structure completely and will give you design results, and you should be capable of interpret, or you should capable to validate that design result. So you need to ensure whether all the members are passing the design check or not. You need to know what does mean by these numbers. Here the some top and bottom numbers you are getting, some of these with 3 digits, 4 digits, what it means. So these are the reinforcement for the beams. Some in vertical, here it is what reinforcement is showing. These are the reinforcement for your column. So you need to ensure that whether the software is properly following or not your code, whether it is following the minimum and maximum reinforcement criteria were suggested by the code or not. Okay, and also suppose this particular beam if I am taking, so the values that you are getting here as 980, 220, 1110 mm, so these mm square, these are the reinforcement areas required at the top, required at the bottom, required on the left, required on the right. So there is a very interesting discussion about the design, detailing, scheduling of this particular beam. But here again, if suppose this beam is failing, so I just want to know what is the reason of the failure. And or in some situation, if suppose the reinforcement requirement is we are getting very high, which is as per our expectation is very high, then you have to ensure whether the software has done this design right or wrong. You have to validate the result. So you need to look inside of that particular beam. What is the shear force? What is the bending moment? What is the torsion? What is the movements? How much the torsion, how much the shear is there, and with that all values you have to cross check with the manual design of the beam. We are having this excellent level of advanced Excel sheet for the design of the beam. So with this Excel sheet you can design every type of the beam, as fixed beam, as simply supported beam, as cantilever beam, as continuous beam, all that kind of beam you can design. So by taking this analysis data of this ETABS software for this particular beam, if suppose you are getting the result here, so I can validate this result by my advanced Excel sheet. Okay, so like then only we are going to ensure we are going to trust on the results of the software, and we will take for the design, for the schedule and detail. So like for that kind of things we are trying to cover. Likewise for the column, if suppose any column is failing, suppose this particular column is going to fail, so I need to know what is the reason of failure of this particular column. Whether this column is short column, whether column is long column, whether this column is cylinder column, whether what is the effective length factor was calculated by the software, what does mean by this effective length factor, how this effective length factor is going to influence, what does mean by the interaction diagram, how to understand this interaction diagram, how to read these detailed results of the detailed calculation of the ETABS software. If suppose the column is going to become long column, how much the additional movement will be there. Okay, suppose the software is what designing and it is asking that 1.7% of reinforcement we have to provide in this column. So suppose my intention is that this percentage should be only 1%. So I will cross check the result of this ETABS software with my advanced Excel sheet, which is having to design for the biaxially loaded long column, cylinder column. So by using this spreadsheet you can design. You just only have to put analysis results of the ETABS software in this Excel sheet. This will give you the design result, and then only you can decide that whether the software has done the things right or wrong. Okay, so for the column, after the column, then we will look at the slab design. For the slab design we are using the advanced Excel sheet for the one-way slab, two-way slab. Okay, these are one-way slab design, two-way slab design, continuous slab design, staircase design, everything we are going to cover, because you all know slab we are not designing by the ETABS software, staircase slab we are not designing this ETABS software, foundation we are not designing. So for that we are going to take the help of our advanced Excel sheets, and this is not the practice we are going to done only. It is the practice we are done by most of the consultancies, most of the independent consultants, right? So like once you complete this, then the next step is going to start about the scheduling and detailing. Okay, so like we have to prepare the schedule of the beams. Okay, so what does mean by the schedule of the beams? Okay, so we, in respect of your ETABS result, we have to prepare the schedule, how much the reinforcement required for a particular beam, at its top, at its bottom, at its left, at its right, what does mean by the curtailment, how much the length of the hooks, okay, how much should be the development length, everything we should try to understand. If suppose you are going to detail the cantilever beam, how much the projection back side of the cantilever, okay, how much the shear reinforcement, what should be the spacing of the shear reinforcement, okay, from where you have to position your first stirrups. So everything comes under the scheduling and detailing, especially we can call it as detailing. Okay, so which code you have to refer for the detailing is your SP34. So we are going to look at in deep all the clauses of SP34. That SP34 will tell you how to detail, how to schedule your structure, design structure. Okay, so with all that studies and practices, we are going to prepare the schedule of your column, schedule of your beam, schedule of your slabs, okay, and then schedule of your foundations. Every element we are trying to cover. So from architectural plan to final design sheet, everything we are trying to cover for all the elements. Thereafter we will talk about the design of overhead water tank, underground water tank by using our advanced Excel sheet. Here it is what ready now. Overhead water tank, how to design that overhead water tank, underground water tank, how much the vertical reinforcement you have to provide, how much the horizontal reinforcement you have to provide. Okay, so lot of things are there. How to do the calculation for the water load over your structure, how to calculate the consumption of the water, how much the water required for a particular structure for a particular number of persons. Okay, so that all things we will do in detail. With that we will complete the design of the overhead underground water tank, and then we will prepare the details. Okay, and you all know at different stages we are going to use the advanced Excel sheets, and there are not only one and two, there are many spreadsheets we are going to use to complete the projects. Okay, so that all you will get, or whatever the Excel sheets we are going to use for the completion of the project, that you will get in the cost of the training only. There will be no extra cost for these spreadsheets, for this advanced Excel sheet. Okay, so with all of this, after the completion of the project, now if suppose you are going to complete scheduling and detailing for any project, like suppose G plus 5, 6, 7 floor, so it takes hell lot of time. It takes about 4 to 5 hours if you are going to do the things manually. Then the need of these RCDC software will come into the picture, that this RCDC software will help you to complete your work within a short period of time. So the time required for any project, for any structure, for its scheduling and detailing, suppose it is 4 hours. So that work with the help of STAT RCDC software you can complete within a 30 minutes. In a just a single click, it will give you all layouts, it will give you all design result, it will give you schedules, it will give you complete details. So like you have how to export the results, how to export the results of ETABS software, then how to import that results in your STAT RCDC software, what problems you may need to face, and if suppose any kind of problem you are facing, how to tackle that problem while exporting, while importing that all results. And then you have to prepare the schedule of the beam, and then you have to prepare the details of the beam. See, in just of single click, this kind of complicated drawing sheets you are getting, drawing reports you are getting. Try to understand. Just think about if you are using the CAD, if you are going to do manually all this detailing, so how much time will you need to have for its completion. So it takes hell lot of time. That's why what we are going to study about this STAT RCDC software. Okay, then how to design the column, how to detail this column, how to draw the sectional details by using Excel sheet. In just a single click, all this thing has been done. Okay, I have not done anything. Software has done everything. It will give the sectional detail, the slab design results, everything will be there. This is a layout of the reinforcement. Okay, so this is what, in this way we are going to complete the design for all the elements. We will talk about the column, we will talk about the slab, we will talk about the foundation, we will talk about the beams. Okay, so all the elements we are trying to cover in STAT RCDC software also. So first we will do manually, and thereafter we will look at the software. So knowing of the software is not only the solution. I am going to cover first manually. I will let you know all those things, then I will take you all on this software. So you will have the knowledge about the from basic to software, everything you are getting. Okay, thereafter In this way, we are going to complete this intermediate level. So you can understand with all that study whether you will be confident or not to deal any project. Okay, so we are giving the experience of real practice. That is what the objective of this intermediate level. Okay, so in the beginner level, we are making you confident with the software. In intermediate level, we are giving the real experience for dealing the real example project. And now the third level we are going to start, that is what? Advanced level. Okay, in this advanced level we are going to take advanced high-rise structure. Okay, in that high-rise structure, lot of things we are going to we are trying to cover that is not covered in your medium rise structure or in intermediate level. Okay, so lot of things, what are those? Try to understand, like what is the concept of stiffness, ductility and strength, what is the role of these different parameters, what will happen if your structure is having the less stiffness, less ductility, less strength, and if it is having very high stiffness, very high ductility, very high strength. What does it mean by the earthquake loading? What does it mean by base shear? What does it mean by the lateral forces at different floors? How it is coming? What is the manual approach for doing the calculation of the earthquake loading? Okay, manual calculation for the earthquake loading. What does it mean by the lumped masses? Okay, what does it mean by the base shear? What does it mean by the zone factor? What does it mean by the response reduction factor? These all values you have to put in ETABS software. So for whatever the values you are going to put in ETABS software while the assigning of the different loads like earthquake load and wind load, if you are not having the basic knowledge about that term, like suppose response reduction factor R value, many of you are knowing as what? For the R you have to put if you are going to do the ductile detailing, you have to put it as 5. And if you are going to do ordinary detailing, you have to put it as 3. But many times when I'm asking to students or participants why you are going to put as 5, why you are going to put as 3, so they are like not in the state to answer this question. Okay, so regional study we are going to cover here, like how much the base shear is there, what is the zone factor, what is I say by G value, what is the seismic weight, what is the general weight. Okay, so these all things we will cover with a manual approach. Okay, thereafter is what? Earthquake wind load calculation. What are the different methods for the static method of analysis, for the dynamic methods of analysis, when to perform static analysis, when to perform the dynamic analysis, what is included in static method, what is included in dynamic method in respect of earthquake loading, in respect of wind loading, what does mean the modal analysis, what is the concept of meshing, what will happen if you are not going to assign the meshing, when to perform the P delta analysis, which code it is asking to perform the P delta analysis, what is the property modifier, stiffness modifier, strength modifier, what is the role of that property or stiffness modifier, what is the load combination for the high rise structure. Okay, if suppose you are going to deal this medium rise structure, G plus 4, 5, 6, 7, 8, 9, 10 number of floors, so and if it is orthogonal building, so load combination will be different. But if you are going to deal high rise structure which is non-orthogonal, what does it mean by the orthogonal building, what does it mean by the non-orthogonal building? So for the case of non-orthogonal building, what load combination will be there? When to consider the earthquake effect in Z direction, everything we are trying to cover. Okay, then what does it mean by the modal analysis, what is the stability checks, whether torsional irregularity in the structure, everything we are trying to cover in detail for this high rise structure. Okay, so how to assign the wind load over your structure at different floor. If suppose structure is 20 floor, 30 floor, 50 floor, so over the height of a structure, how to calculate the wind load, that we will see in detail. Okay, and what is the modal analysis, what is the modal response. So IS code has suggested that we have to perform the modal analysis, and in that modal analysis we have to check is there any torsion in your building or not. If your structure is subjected to any torsion, you have to remove that torsion. So here this is the modal analysis result. So in the first mode, as you can see, it is what? Free from torsion. In the second mode, it is having the torsion. In the third mode, there is also presence of torsion. So you have to remove the torsion from the structure from the first mode and second mode. So what actions you have to take to avoid the torsion from the first mode and second mode? And in the third mode, if the torsion is present, that is what acceptable. So like what is the modal mass participation? What is the base shear? What is the I can say scaling of the base shear? How to do the scaling of the base shear? Okay, what is the maximum lateral deformation limit, maximum displacement limit? If your structure exceeding the maximum deflection limit, what to do with that? Okay, what is the base shear? How to scale the base shear? So these all things we are going to cover in this high-rise structure, so that after the completion of this third level high-rise structure or advanced level advanced level, you will be able to deal any kind of high-rise structure, and you will be able to do the stability analysis, stability checks for that particular structure. So in this way we are going to cover this advanced level. Okay, so these all are the content of this complete training program. Okay, so like as we have earlier said that this training program is going to start from 1st of February. Most of the registration has been done. Registration has been started. From 1st of February we are going to start. So like if you would like to join this training program, so don't think about if you like to succeed in your career, or if you are beginner in the field of structural engineering, you have completed your bachelor, you have completed your masters, or you have done your job for 1 year, for 6 months, and you want to scale up your knowledge, your experience. So this is the best choice. Don't miss it and join the training program. Okay, here daily live classes will be there in evening from 7:30 to 9, and that live classes you will get as a recording in just of 2 hours. Like suppose we are going to start the session at 7:30 and it is going to complete it at 9 o'clock. So in between 11 or 12 o'clock in evening you will get the recording of that particular session. Live interaction will be there. You can ask your doubts and question anytime with expert. We are giving the real experience. You will get the certification. Okay, so after the completion of training program you will get the certification also. So you are getting the experience as well as certification, and till now, like I can say, the more than 1,000 people have joined this training program, have benefited from this training program, have placed in many of the reputed consultancies also. We are not giving the support, but actually after learning these things from here, they have achieved that levels. They got the entry in that in different consultancies on their own. So after the program you will get the confidence. Okay, and see, as I told you, registration has been started. Training start date is 1st February. Session timing will be 7:30 to 9, and the training fee is 5,000 only. The content and the things that we are providing, it is the worth of 50,000. If you are having the knowledge, you can search into the market. It is the worth of 50,000, and that 50,000 content we are trying to give in just of 5,000. So if you would like to join this training program, so you can contact on this given number 8857891345. And if you like to if you have decided to join it, you can pay the fee to GPay, PhonePe, Paytm, whatever you are having. Once you done the payment, you have to share the screenshot on this given number. Or if you want any further details about this training program, you can contact on this.